In this video, we'll be learning how to add and subtract rational expressions. So on the screen here, you can see the formal definition for adding and subtracting rational expressions. The important thing to note here is that whether you are adding, like you are here in this first example, or subtracting in this second example, the thing you need to note is that we always need to have a common denominator. So just like when we added and subtracted, fractions previously in our math careers, we need to have common denominators when we're adding and subtracting rational expressions. So as long as we have common denominators, what we can do is we can either add the two numerators together or subtract the two numerators together to create a new expression. So when we have common denominators, this process is actually pretty easy. So here you can see we have, in the first example, a common denominator of 15x. Because we have a common denominator, we can add the two numerators together. So if we add these two together, we end up with 27 over 15x, because we leave the denominators alone and we add the two numerators together. Then in the case of this problem, you'll notice that both 27 and 15 are divisible by 3. So we can simplify this fraction a little bit and it would become 9 over 5x. Then if we look here at example 2, while subtraction is a little bit more complicated, when we have common denominators, it's pretty simple as well. So what I always suggest students do before combining things together when they have subtraction is that you take this subtraction and you acknowledge that it's going to be basically distributed out to both of these. So I like to turn this into an addition problem first. So here we're going to turn this into 8x cubed over x minus 2 plus, then we're going to distribute this negative 1 out to both the 4x cubed and the 16x squared. So here this would become a negative 4x cubed plus 16x squared. Notice the signs of each changed. And then from here, because we have common denominators, we simply add the numerators together. So this becomes 8x cubed plus a negative 4x cubed plus 16x squared all over the common denominator of x minus 2. And then we can combine our like terms together. So I see that I have 4x cubed plus 16x squared over x minus 2. Now, if you want to make sure that you don't have anything else that you can simplify out of this particular expression, you do need to factor that numerator a little bit further just to make sure. Well, I notice these both have a GCF of 4x squared. So if I factor out a 4x squared, I end up with 1x plus 4, which I notice can't be simplified with my denominator. So this would be my final answer. It doesn't simplify any further. So while this process is very simple when we have common denominators, it does become a little bit more difficult when we do not. Now, I know what's on the screen for both addition and subtraction here looks complicated. However, this is actually what we do when we add typical fractions. So say we had something like, 2/3 plus 1/2. So in this case, the 3 would be my C and the D would be 2. So in this particular example, I want to add, two basic fractions together. What we know that we do is we take the first fraction and we multiply it by the denominator of the second. So we multiply it by D. That's what we're doing here. We then take the second fraction and we multiply it by the denominator of the first. So we multiply it by C. That's what we're doing here. And as we do that, we end up with a new denominator, and we eventually are able to add them together. So here we end up with 4 over 6 plus we end up with 3 over 6. And essentially what I'm finding is I'm finding a common denominator for the two fractions by multiplying by those opposite denominators. Now when I have the common denominator, I can simply add it together to get a final answer. So we're going to take this process that we walked through when we've added or subtracted fractions in the past, and we're now going to apply it to our rational expressions using that same general idea. So in this slide, we're going to apply this idea of common denominators to rational expressions. So here we'll notice that our first denominator is 9x squared, and our second denominator is 3x squared plus 3x. So what we're going to do is we're going to take that first fraction and we're going to multiply it by the denominator of the second. Now I strongly suggest using parentheses to ensure you don't make an error. So we're going to multiply the first numerator by 3x squared plus 3x, and the denominator by the same thing. Now if you want a little more space, you can write this out here instead. Then if we look at the second one, we're going to multiply that by the denominator of the first fraction, which is 9x squared. So I'm going to multiply this by 9x squared, and I'm going to multiply this whole thing, so I'm going to put it in parentheses, by 9x squared. So we end up with plus x times 9x squared, and then we have 3x squared plus 3x times 9x squared. So we'll notice that our denominators are now the same thing. So because of this, now let's simplify it just a little bit before we start adding together. So I'm going to distribute the numerator. So I'm going to find 21x squared plus 21x over, I'm just going to leave the denominator as is. I'm not going to unsimplify it. So then the second one becomes 9x cubed. And then the denominator, because I have the same two terms being multiplied down here, it doesn't matter which order I multiply them in, so I'm just going to write them in the other order so that I can see very clearly that these two denominators are the same. So now, because I have two denominators that are the same, I can add their numerators together. Now, because I know I might be factoring further, I'm just going to write them in descending order, so the biggest exponent first, and then I'm going to combine like terms as I combine them together. So I see that I have 9x cubed. That's the biggest one. Then I notice I have 21x squared plus 21x, and that's all over 9x squared times 3x squared plus 3x. So it's all over my common denominator. So that's the process of adding. I get common denominators, and then I add the numerators together. Now what I also need to do here is I need to simplify this to make sure that it's fully simplified. In my numerator, I notice that I have some pretty large numbers, so I'm going to try to factor out a greatest common factor first, if I can. And what I notice is that these all have a GCF of 3x. So I'm going to factor out a 3x here, and then I end up with 3x squared plus 7x plus 7. Then in my denominator, I'm going to look, now this I know can't be simplified any further or factored further, but here within this parenthesis, I notice that I actually have a greatest common factor of 3x as well. So I'm going to leave the 9x here, the 9x squared, but then I'm going to factor a 3x out of that parenthesis piece to get x plus 1 instead. So now I notice that I can, in fact, cancel something out. So I can make this a little bit simpler. So the 3x and the 3x cancel out. Now I look here and I try to think through, okay, I have a trinomial. So I'm going to look at the a, b, and c values. So I notice a is 3, b is 7, and c is 7. So I'm going to need two numbers that multiply to a times c, which is 21, and add to 7. And just based on my knowledge of the factors of 21, I can't think of any combination that will work for that. So that doesn't actually factor any further. So my final answer here, the most simplified version of this that I can find, is 3x squared plus 7x plus 7 in my numerator, all divided by 9x squared times x plus 1 in my denominator. Now before I can be completely done here, I do have to note any x values that cannot be used. Because I crossed off this 3x in the denominator here, I do need to note in my final answer that x cannot be equal to 0. So now let's move on to our second example. We're going to use this same idea here. So here we're going to have a subtraction problem. So before we even begin, we're going to turn it into addition by multiplying everything in the numerator of the second fraction by -1. And then from here, we're going to start by getting common denominators. So I'm going to start by multiplying the 3x and the -4 by x plus 5. So here I take 3x times, in parentheses, x plus 5, and then my two denominators become multiplied, so it becomes x minus 4 times x plus 5. Then have plus, I'm going to take -7 and x plus 5 times the x minus 4. So I have -7 times x minus 4 all over x plus 5 times x minus 4. So regardless of the order that these two denominators are written in, because I'm multiplying the same two terms together, I know that they are now a common denominator. So I'll be able to add my numerators together. Before I do that, however, I'm going to distribute to make this a little bit simpler to look at. So I end up with 3x squared plus 15x all over x minus 4 times x plus 5. And then I have -7x plus 28, and I'm going to use that same denominator order of x minus 4 times x plus 5 because I can switch those multiplications around and they are still equivalent. So now I'm ready to add my numerators together, and as I do this, I'm going to write them in descending order, so highest power first, and then combine any like terms that I see. So I notice that the highest power is 3x squared. I then notice that I have a 15x and a -7x that can be combined together to be plus 8x, and then I have a plus 28 off to the side. So before I can state that this is my final answer, I need to look and see if I can simplify anything further by factoring things out more. The denominator I know is fully factored. The numerator, I can look and see I don't have a greatest common factor here. And if I look at the ABC method, I would need to multiply a times c. So 3 times 28 would be 84. So I need two numbers that multiply to 84 but add to 8. And there really aren't two numbers that do this. 8 is so small, and I would need two numbers that multiply to 84, and that's so large. And because of that, I know that I can't factor this further, and this is my final simplified answer. So while simply multiplying by the other denominator can be a really easy trick to use, if we get a really complicated denominator, that can actually make our problem pretty complicated to solve because we'll have to do some complicated factoring later on. So what we can also do as we find common denominators is we can make sure that we are finding what is called the least common multiple, which is basically just saying we're finding a common denominator, but it's the smallest common denominator. So we're being very purposeful about it. What we need to do if we're going to take this approach is we always need to make sure that our denominators are in a completely factored form before we actually start to find a common denominator. So if I look at the fractions in front of me, I notice that this is in a fully factored form in the denominator. It doesn't factor any further. X minus 3 is pretty simple. But what I notice when I look at the second fraction is that this particular polynomial down in this denominator is not fully factored. So what we're going to do is we're going to factor it further and then kind of look it over and see if we're close to having a common denominator or if we need to do something more. So here, to factor this further, I'm going to look at my a, b, and c values. So I notice that we have a is 1, b is -8, and c is 15. So I would need two numbers that multiply to a times c, which is 15, add to -8. And if I think about my factors of 15, I find -5 and -3. So what I can do with this first fraction here is I can rewrite this as 5x plus 6 over x minus 5 times x minus 3. So what I can now do is I can take a look at, I'm going to bring this first fraction down, is I can take a look at the two fractions and I can note their denominators. What I note is that they have in common this x minus 3. However, what they don't have in common is this x minus 5. Now we cannot take the x minus 5 out of the denominator of the second fraction, but what we can do is we can multiply both the numerator and the denominator of this first fraction by what it's missing, the x minus 5. And if we do that, we're going to create a common denominator because we're all of a sudden going to have x minus 3 times x minus 5 as our common denominator. So this first fraction would become 2 times x minus 5 in the numerator. Then the denominator, we're multiplying the same two little expressions that we were multiplying over here, so we can write them in any order. So this becomes x minus 5 times x minus 3. I then still have the 5x plus 6 over x minus 5 times x minus 3. So here we can see that we now have a common denominator. So we didn't need to multiply by x squared minus 8x plus 15 to both of these. Instead, we could look at what that looked like in factored form and discovered that the second fraction was just missing an x minus 5. So now we can distribute this out. Just for saving some space, I'm going to do that right here. So I have 2x minus 10. So now I can add all items together, combining any like terms that I see. So I end up with the 2x and the 5x combined to be 7x. Negative 10 and 6 combined to be minus 4. And then I have x minus 5 in my denominator and x minus 3 in my denominator. And I can see from just looking at this, the denominator is fully simplified. The numerator is also fully simplified. It's not going to simplify further. They don't have a greatest common factor. And no factoring strategies will make that smaller. So there's our final answer. So let's apply this same idea to one more problem. Now to note, first on this problem, I notice this is subtraction. So I'm going to need to multiply both items in the numerator by a negative 1 and turn this into addition to start. So I'll have 6 over 4x squared plus negative 3x minus 5 over 12x cubed minus 20x squared. So then from here, I take a look and I notice that I have two different denominators, but I notice the second one is not fully factored. So I might be able to find a least common multiple. So if I look at these two, I notice they have a greatest common factor of 4x squared. So if I factor out a 4x squared in my denominator there, I end up with 4x squared times, well, 12 divided by 4 is 3, then I have an x left, and then 20 divided by 4 leaves me with that minus 5, and then the x's cancel out. So what I notice here is that these two fractions already have a 4x squared in common. The second fraction is just missing the 3x minus 5. So I'm going to multiply each of these by 3x minus 5. And in doing so, I end up with 6 times 3x minus 5 over 4x squared times 3x minus 5. And then I have plus negative 3x minus 5 over 4x squared times 3x minus 5. So I now have that common denominator that I need to add my fractions together. So now I can distribute out this 6, so I get 18x minus 30. So that's what's left in my numerator. And now, because I have common denominators, I can now add my numerators together and combine like terms as I do so. So 18x and negative 3x become 15x. And then negative 30 and negative 5 become a negative 45. So now if I write this out with my denominator of 4x squared times 3x minus 5, I do want to make sure that this is fully factored, so I'm going to look in my numerator and see if I can use any factoring strategies. The only thing I notice is these have a greatest common factor of 15, so I can factor that further to be 15 times x minus 3. But what I notice is that even if I factor that numerator out, it doesn't cancel out with anything in the denominator, and as a result, this is my final answer.